using equation to solve a kinematic problem with constant acceleration, we can use this table. In each question, there are always the 5 variables: initial velocity, final velocity, time, acceleration, and displacement. We just figure out what we know, what we do not know, and then pick an equation to solve them. So read the question. An aircraft that lands at a speed 150 km per hour and is uniformly accelerated at negative 1.2 meter per second squared. So negative acceleration in this case obviously means it's decelerating, and it's because aircraft landing, so we have an initial pretty big velocity, and then take some time, it's going to come to a stop. So obviously the initial velocity is 150 kilometer per hour. Final velocity should be 0, so that's implied. It's because it has to come to a stop. The time, actually, we don't know. We need to find it out. Acceleration is negative 1.2, and the displacement, or the distance covered, we don't know. So here there's no difference between displacement and distance because it should travel along a straight line. Okay, so to find out the time, we can just use this formula. V final equals V initial plus a t, right? So we can isolate the t, and you should get this. V final minus V initial divided by a. Okay, now for the initial velocity, it's given as kilometer per hour. We need to change it to meter per second. Kilometer per hour. So we need to multiply the two converting factor. So one is, so 1 kilometer equals 1,000 meter. Another converting factor is 1 hour equals 3600 second. Now this will give you 41.67 meter per second. Okay, we can plug in. Final velocity is 0 and minus 41.67 meter per second divided by the acceleration is negative 1.2 equal to 34.7 seconds. Okay, so that's A, finding the time. For the B, you need to find the distance. There are a couple of formula you can choose from, right? You can actually use the D equals V initial t plus 1/2 at squared, or you can use V final squared equals V initial squared plus a 2ad, right? Because you know everything else except the d. And actually I prefer use this one. So the displacement is equals average velocity multiplies the time. What is average velocity? It's v initial plus v final divided by 2 and then multiply the time. Okay, so I'm just gonna use this. Initial velocity is 41.67 plus final equals 0 divided by 2 multiply the time we got from here 34.7, and that gives you the displacement. Should be 7 to 3 meter. Okay, now basically it's done, but I like you to show you how to draw the VT graph. So look at it here. So the VT graph is really going to help you to understand the situation even better. Velocity, meter per second here. So that's the time. So this is a case we should have a velocity time graph like this. Starting from a velocity at 41.67 and then to zero velocity, and it took 34.7 second, right? And then initially actually the question told you that the slope, which is acceleration, is negative 1.2, right? And then the area is going to be the displacement, right? So this is the area is actually the displacement. Okay, so you can even solve the problem without using all the kinematic equation, just using the basic concept. See how to find the time. You can use the rise over run. Of course, the run is actually negative 41.67 divided by the time, which is that's the rise over run. The run is the time, and equal to negative 1.2. That way you can find out the time. And once you find out time, you can just simply find the area here. That would be the distance covered by the airplane.